In this video, we'll continue our discussion of section 4.4. This is a method using undetermined coefficients. The whole point of this was I can look at this right side and I can take a guess towards a solution because of that form. So remember, to find this general solution, we're going to have to do the homogeneous solution to the corresponding homogeneous equation plus a particular solution. So we're going to define both. All right, so starting off, my homogeneous equation is just y double prime times 2y prime equals 0. Okay, we switch this to m squared plus 2m equals 0. All right, well, that's going to lead us to having two solutions. If you factor, you get here, and that tells me that the solution is 0 and -2. So we get y equals c1 e to the 0 x plus c2 times e to the -2x. All right, well, I could rewrite this. This is my yc. So yc is equal to, this is going to just be c1 plus c2 e to the -2x. Okay. I'm going to move this just for the sake of room. You might have enough. You probably write a lot smaller and neater than I do. Okay, I won't do much more moving here. All right, so we have that. And really, if we were labeling everything, that should be a C there. All right, now I'm going to look for my particular solution. The reason I know to do this is, one, I have constant coefficients, and then this looks like a form that I can create. So seeing the 2x, this tells me that we probably have, okay, and there's a couple things we're going to have to look at here. Probably an ax squared plus bx plus c maybe. The reason I'm choosing all the way up to the square here is because this 2x, if I only do like an ax plus c or b, something like that instead, well, notice that we don't have y in our equation. There's no plus y. It's just a double prime. So what that tells me is that I probably should go up to the square, because if I'm only going to take I'm not going to have the original function, but I need an x. I need to have something that when I take a derivative, I still have that x, and that would be the square. Okay, so that's one way to tell. This is what I was talking about. That's kind of difficult, and all the methods are a little different. You got to kind of just think about it. So I know that since there's no y, that just using an ax plus b is not going to work. All right, and then now you would think, okay, I'm going to write this. Maybe don't write it yet, okay? We would do this next to cover this. Now, here's the problem, though. If this is the solution, well, if you look, this is this form. It's the same exact thing. So I know that if that's the form I'm going to use that's right here, then it's just going to make my left side of my equation up here 0. That was the solution to my homogeneous case. So how I take account for this is, instead of just doing a d, I'm going to multiply it by an x. This was back from the solution 4.3 right before this, where we were choosing finding our m's for the constant coefficient homogeneous case. And if we had this as a solution, the next solution for repeated roots would be to add an x. All right, so we don't have any repeated roots here, but it happens, this thing, we just have to keep an eye out that none of this is going to hit the form from our homogeneous case. So that's why I added an x, because it was already here. Okay, now this is where a lot of the work comes in too. Depending on the function that you guess, I got to work my way up to the second derivative. So I get ax plus b, c is gone, and then this is a product rule. So the x is gone. Then I'm going to introduce the 2 from the -2x, x e to the -2x. That was just a product rule. So please take the time if you need it to see what happened there. To make my life a little easier, let's see, I didn't really do it in my notes. No, we can just keep going. Okay, y double prime of p, all right, is going to be 2a. The b's gone. Then I get -2d to the -2x. That's the chain rule for that one. And then now I have another product rule. So the x goes away. And then the next one, I'm just going to introduce a 2, keep the x, and that was the derivative of the e part. All right, so there's the double. I think that's all I have to go up to. Now, looking at my equation, I do need a 2y prime. I like to just do that here so I don't have to throw a bunch of stuff in an equation. I can just add down. All right, so that's multiplying everything by 2. So now yp double prime plus 2yp prime, right? I can only add things that, okay, so and I'm going to kind of group things up. 4a times x, that's the only x term. Then I'm going to group my constants, 2a plus 2b, right? And then everything else has an e to the negative x, but some things work out here. This is gone with that. This is gone with that. So I just get a minus 2dx. Or no, the x is it gone? Let's see. Just these two. I think I'm trying to add more than what was there. There we go. Okay, yeah, so 4d, those are gone. I don't have an x down here. It's just minus 2d e to the negative 2x. There we go. Things canceled, which is nice. Okay, so now I can create a system. 4a must equal, okay, if I go back up, that was a 2. 2a plus 2b is equal to 5. And then the last thing, negative 2d, should be equal to negative 1. All right, so if I solve all those, this is my system. I get a is 1/2, right? If a is 1/2 and I plug it in and solve, I get 2. And then the last thing is d is 1/2. Now notice that the c went away. Well, that's because and this goes back to our reasoning up here, that this equation doesn't have a y anymore. So if I don't have a y in there, then whatever the c was, given that both of these are derivatives, right? That c is just going to go away. So you could literally choose whatever c you want. So I'm going to choose c equals 0, just to make it easy. All right, so now I can plug in my solution. Okay, I got 1/2 x, was it squared? Yes, 1/2 x squared plus 2x plus 1/2 x e to the negative 2x. Then to get our overall solution, we have y equals c1 plus c2 e to the negative 2x plus what we just came up with. These are going to take some reps to understand what comes next. It is the same method every time. On an exam, I probably wouldn't, these problems here in a bit are going to get 2 pages long. I think there's one that might be a little bit longer than that, depending on your handwriting. But it's going to get pretty long. And on a test, I can't really give you one of those long problems because you only have a certain time limit. So the method is important. And if you take a look at the exam one and you go through the problems that I chose were all really method based. If you take a look at the integration, I think most of the integration was pretty straightforward. I'm really seeing if you know the method. All right, we're gonna do one more in this video, trying to split it up. All right, so I see that I have constant coefficients. And then I also see that this is a pretty predictable form. So let's do our homogeneous case first. So y double prime minus 16y equals 0. And then just be careful with this. This is where people mess up. It's m squared minus 16 equals 0. All right, people put m with the y, but the y is the constant case. All right, well, that is m equals plus or minus 4. So my complementary homogeneous case will be c1 e to the 4x plus c2 e to the negative 4x. All right, so we have that solution. We'll come back to that. So my guess here is pretty straightforward. Okay, I got to be careful. I do have this here. So I can't just, and look, that like matches that form. So I can't just use that because I know that that gives me a 0. That was that whole point. So my new guess then would be just up the chain. I multiply by an x. If that x was there, like in my solutions, I had like x e to the 4x maybe in the second one, then I would add x squared. If there was an x squared, I'd add an x cubed. It's there's a rule there that we'll talk about in a moment. All right, so there's my guess. So let's go through each one. Okay, I got y prime, or yeah, y prime. All right, and it's a chain rule, so I'm gonna get c1 um, Oh, no C1. Let's use A. I don't know why I chose a C1 there. A e to the 4x. That's multiplying with the e, or sorry, the derivative of x, and then I get 4ax e to the 4x. That's the derivative of e to the 4x. So I need yp double prime now. That's going to be 4a e to the 4x. That's just the derivative of that term. And then now I have another chain rule. It's going to be 4a e to the 4x, derivative of x is 1, and then plus 16a x e to the 4x. All right, so I'm going to have that, and then I need a negative 16y. And that's going to be my left side of my diff q. So if I do that, I get a negative 16a x e to the 4x. So we can put these together now. All right, if I'm subtracting, now be careful, we don't need to think subtraction, we just add the two lines because I already gave you a negative there. So I'm going to get 4a e to the 4x. Oh, there's two of them, so I'm just going to have 8a e to the 4x, and then the 16a ax e to the 4x. Those are both gone. So this is a nice easy system. 8a equals 2. That was what was up here, right? The 2. So that means a is a fourth. So my particular solution then is going to be 1/4 x e to the 4x, which gives me a general solution of c1 e to the 4x plus c2 e to the negative 4x, and then I put on the particular solution. So notice the method is very, very repetitive. You just got to be able to know when to use it. How to know when to use it would be when you see constant coefficients, and then you see that the right side is some type of predictable function. The beginning of the next video, I'll give you a list of guesses that'll help, and then we're going to start making that right side a little more complicated moving forward in these videos.